All right, welcome back everyone. In this video, we'll finish up this section on solving linear equations by looking at how you solve equations that contain fractions or decimals. So the overall guidance or guidelines for this are that you can multiply both sides of the equation using the multiplication property by the LCD of the denominators of those fractions. And we'll see with the decimals, there's a very similar statement that can be made. So the other thing that can be said about this is that you could just follow the steps that we have all along to solve these equations, but usually people find fraction arithmetic a little bit challenging or cumbersome. And so people typically desire to get rid of those fractions whenever possible. But let's see how this looks if we're going to multiply both sides by the LCD of our denominator. So our denominators in this equation are 8, 2, and 4. The LCD is going to be 8. And so we're going to multiply both sides of our equation by 8. We know that the multiplication property says you can multiply both sides of an equation by the same non-zero number. And an equivalent equation will result. Usually we use that to finish an equation, but here we're using it to start by eliminating the fractions. So we've multiplied both sides by 8, and so let's distribute now. So we'll have 8 times 1/8x plus 8 times 1/2, and then 1/4 of 8 is going to be 2 on the right side. Okay, 8 times 1/8 is going to be 1. 8 times 1/2 is 4. Okay, and now we should be free of the fractions, right? So we can subtract 4 from both sides, and we'll get -2 for a solution. So you should be able to multiply both sides of an equation by the LCD of the denominators to remove those denominators. If after this step, there are still fractions left, then either you pick the wrong LCD or maybe you multiplied incorrectly. Once the fractions are all gone, then you continue just as we had done before. Okay, all right, let's try the next one. We have in this one, 7 is 1/2 of x plus 3/4 of an x minus 2/3 of an x. So the LCD for 2, 4, and 3 is going to be, okay, so 2 divides into 4, and then we also have a factor of 3, so 12. So we're going to multiply both sides by 12. Okay, so we have 12 times 7 on the left side, and then 12 times everything else on the right side. Okay, and so then 12 times 7 is 84. And then here, in the first example, I actually showed that multiplication by 8. And here, in the interest of time, I'm just going to do each one. So 12 times 1/2 of an x will be 6x. 12 times 3/4 of an x will be 9x. And then 12 times 2/3 of an x is going to be 8x. Okay, so we've removed all those fractions. So what's left to do is combine like terms on the right side. So 9 minus 8 is 1 plus 6, that's 7. So 7x is 84. So then 84 over 7 is our x. That will make 12 the solution. Okay, all right, and that will do it. So let's go on to one more with fractions, and then we'll take a look at some with decimals in it. So here we have 3c plus 5 over 6 plus just a whole number 1, and then on the right side 4c plus 3 over 3. So we're going to multiply both sides of this one by 6. Okay, and then an important thing to remember on this is we're multiplying the entire left side by 6. It's very common for people to forget to multiply the 1 there by 6. Just because it doesn't have a fraction that you're trying to get rid of, but it is a member of the left side, so we do need to multiply it by 6 also. Okay, so 6 times 3c plus 5 over 6 will give the 3c plus 5 part. Then we'll have 6 times 1 is 6. And then here, 6 divided by 3 is 2. We'll have 2, 4c plus 3. 3c plus 11, and then this will be 8c6. Okay, we're almost there. Fractions are all gone though, so it's downhill from here. So we'll take away 3c from both sides. And then take away 6 from both sides. And it looks like c is just 1 this time. Okay, as I'd said, the most common mistake in working on an equation like this is forgetting to multiply that 1 by that same number that you're using to get rid of the fraction. So remember that the entire left side and entire right side are multiplied by whatever number it takes to clear those fractions. Okay, all right, so now I want to look and see how do you deal with it if it's decimals. And so kind of the key to thinking about this is to think about the fraction equivalent of those decimals. So just for a moment, let's look at this one as fractions. The 0.25n, that 0.25 is 25 hundredths, right? So let me go ahead and write that out. That will be 25 hundredths n, and then we'd have 5 hundredths, n plus 5. And then the right side is 295 hundredths. Okay, so if it was a fraction like this, we could see, okay, well, we would multiply by the LCD here, which would be just 100. So we're going to multiply both sides by 100. And it turns out that we don't need to write this as a fraction in order to get this done. What's really going on here, a way to think about what's going on, is we can move the decimal point over enough places in those coefficients that the decimals are cleared out. So 100 times 0.25 will just give us 25. And then here 100 times 0.05 will give us 5. And then the right side is 295. Okay, so at this point the decimals are removed, and so we can continue the way that we would have before. So we've distributed to remove parentheses. We're going to combine like terms next. And then that will be 30 and 270 after we subtract the 25 from both sides. So then n is 270 over 30, and that's going to be 9. Okay, so 9 is our solution for this one. Okay, on this equation, we saw that all of the coefficients here had 2 digits behind the decimal point. In our next example, we'll see how it looks if that's not all the same. All right, so in this example, we can see that there's 4 terms in the equation. The 2 terms that contain x's have 1 digit behind the decimal point, and then the 2 constant terms have 2 digits behind the decimal point. Again, for guidance, we're going to look at this as if all of the coefficients were fractions and see what we would do. So if we turn all the ones with 1 digit behind the decimal point, like this 1.2, we'd make that 12 tenths. If we do that throughout the equation, we end up with this 12 tenths x minus 91 100ths, and so on. So the denominators we have are 10 and 100, and the LCD for 10 and 100 is going to be 100. So we're going to move the decimal point over 2 places throughout. So if you don't want to write it as fractions, which is totally reasonable, then take a look at how many digits there are behind the decimal point in all the numbers. There's 1, then 2, then 1, then 2. What's the biggest of those numbers? 2. You're going to move the decimal point over 2 places in all of the coefficients because you're multiplying both sides by 100. So we're going to multiply by 100, which has that effect of moving the decimal point over twice. If you move the decimal point over 1, it would still be an equivalent equation. It just would still have decimals in it. Okay, all right. So then 100 times 1.2x is 120x. We'll have minus 91. On the right side, we will have 80x and 229. All right, so at this point, the decimals are all gone, and so we'll just follow the steps that we'd had before to finish the solution. So let me work on the x's first. I'm going to subtract 80 from both sides. So this will give us 40x minus 91 is equal to 229. And then let's add that 91 to both sides. Okay, so 229 plus, plus 91, that's 230 plus 90, or 320. And so x is 8, looks like. All right, so that takes us to the end of this example and the end of this section at long last on solving linear equations. So in the next part, we'll take a look at some overall strategy for how you solve linear equations, and then we'll move on to looking at word problems. In the meantime, let me know if you have any questions, and have a great day.